Okay, what I wanted to teach you guys about today is breaking up dry matter into different fractions. And we'll do that as we start to balance rations. But these formulas are all going to be derivative of what we have here. So how much dry matter is in the feed? We took our as-fed pounds, we multiplied by a dry matter percent over 100, and that gave us our dry matter pounds. Everybody remembers that, right? From 2 weeks ago. So we're going to break up the dry matter into its different component nutrients. So what are our 6 nutrients? Does anybody remember? Water's one.
Vitamins, minerals,
Proteins, fat. Protein, fat. I help them out.
ones that you were just asking about on the list. Oh,
What?
carbohydrate.
Carbohydrates.
Oh,
Is your 6th one, right? So we're going to try to divide everything up for our feeds. So we're going to separate, the first step is we're going to separate the dry matter from the water. And then we're going to take the dry matter and we're going to divide it up into the different nutrient classes. And you use the same sort of equation that we used before. So this is what we used before. Instead of starting out with as-fed pounds, we're going to start out with dry matter pounds. Then we're going to take whatever component or nutrient that we're dealing with. In this case, CP is protein. Divide that by 100. So if we multiply the pounds of dry matter by the crude protein percent, that's going to give us crude protein pounds in that feed. The dry matter of that feed. And we can do that for any of the nutrients as we go through. So if we take 200 pounds of hay crop silage dry matter, so what would that probably be on an as-fed basis? Anybody want to guess? What would 200 pounds of dry matter be on an as-fed basis for our haylage? What's a typical dry matter for our haylage out here? What'd you guys come up with? You remember? 40, 38, somewhere in there? Okay. So if it's 40% dry matter, what's 200 pounds as fed? What do we have to do? Get from dry matter to as fed, what do we do? What do we do in the homework? Divide it out, and that's going to give us, say it was 40%. What's that going to give us? Probably 500 pounds, right? 200 divided by 0.4 is probably 500 pounds as fed. We're probably looking at something from 400 to 600 pounds of as fed material. Haylage is mostly water, at least over half water, sometimes 2/3 water. So we have the nutrients listed here. We got sugar and starch, NDF, protein as crude protein, CP, fat and ash. What are we missing? What nutrient are we missing? Water we took out because we're on a dry matter basis. What's the other one? You had them 2 minutes ago. What's your missing one? Carbohydrates are up there as what? Sugar and starch and NDF. So carbohydrates are up there twice. Which one's missing? Ash is crude mineral. So you're missing vitamins. Why is vitamins not up there? Because it's such a small amount, we're going to lose it in the weights that we're dealing with. So we break up that 200 pounds of dry matter into its components. In this class, I'm going to probably try to make it so your starch, your NDF, your protein, your fat, and your ask are going to add up to 100%. Makes it easier to check the math. Does that happen in the real world all the time? No. So if we're up here on the board, we take that 200. I guess it's going to be a little difficult if we don't have that up there. We take 200 pounds of dry matter. Starting out with sugar and starch. That's 15% of the dry matter. How do I get pounds of sugar and starch? Multiply it. 15% divided by 100 or 0.15 gives us what? How many pounds of sugar and starch are in that pile? $200 times 0.15 is going to give us 30 pounds. So 200 pounds of dry matter. NDF is 60%. We're going to divide that by 100. That's going to give us how many pounds of NDF in that pile? So 200 times 0.6 going to give us 120. Crude protein, 200 pounds of dry matter times 15 over 100 is going to give us what? 30 again, right? 30 pounds of crude protein. And we continue on with the other two factors, other two nutrients, 200 pounds of dry matter. So is everybody seeing that approach? So how do I check myself? So if this column adds to 100, this column over here has got to add up to 200 or whatever I started out with. Everybody with me on that? Any questions? So if we're looking at our we want to petition a as-fed pile of feed into its component nutrients. It's a two-step process. First, we separate the dry matter from the as-fed into water and dry matter. Then we take the dry matter, divide that up into the nutrient fractions that we're going to deal with. So we're going to do protein, our two carbohydrate fractions, sugar and starch, which could also be called what? Could be carbohydrates. What's the specific name for the sum of the sugars and starches? Anybody remember? Non-structural carbohydrates, NSC. You got your NDF pounds, fat pounds, and ash pounds. Everybody with me? So we're going to do some feeds up on the board. So I want to start out with 2,000 pounds of hay. Want to divide that up into my various fractions. So we're going to start out with a hay that's 12% water. And 88% dry matter. What do we know about those percentages? You have to add up to 100, right? So that's step one. We take our as-fed, split it into water and dry matter. Step one. Step two, we want to split up the dry matter into the component fractions. So we're looking at what percentage of the dry matter is each of the nutrients we're dealing with. So we're going to do protein first, then our two carbohydrate fractions, sugar and starch. NDF, fat, and ash, which, as we'll discuss, is crude mineral. So as a percentage of the dry matter, we're going to say that the protein for this hay is 10%. Sugar and starch, did a reasonable job putting it up, 15%. NDF, grass based, we're 65%, 4%, and 6%. So we give you all that information. Can you divide up? Tell me how many pounds of each is there. So second step, we're going to divide things up. Crude protein, starch, and sugars, and the F, fat, and ash. So first step, we have to split the water from our dry matter. How do we do that? Gonna take that 2,000 pounds of as fed. Gonna multiply it by 0.21, and that's gonna give us the amount of water, pounds of water, in that pile of hay. So we're probably looking at 3 big square bales. How much water is there? 2,000 times 0.12, 12 divided by 100, 240 pounds of water. How many gallons is that? Anybody know? $30 gallons at 8 pounds per gallon. So those 3 bales have 10 gallons of water in each of them. 2 5-gallon pails. Dry matter, same thing. 2,000 pounds of as fed times 88 divided by 100. Going to give us what? Pounds of dry matter. So how do I check my work? These two have to add up to whatever I started with. So 2,000. Okay, so how do I get the amount of protein? What do I do? So I got to get my pounds of dry matter, right? So I take this 1760 and I bring it down here. So 1760 is total dry matter. I got to find out how much of that 1760 is each of my fractions. So I'm going to divide by 100 again, multiply by my pounds of dry matter. So how many pounds of protein do I have in this pile of hay? So 0.1 times 1,760 pounds protein. Starch and sugar. So 0.15 times 1,760 is, what'd you get, Reese?
263.
264 pounds starch and sugar in that pile. NDF. 1,144. Does everybody agree with him? Fat is what? So around that 70 pounds fat. What do we got for ash? 6 pounds of ash. How do we check our work? 1, 2, 3, 4, 5 have to add up to what we started with. Assuming we had 100, these add up to 100%. Everybody following that? Everybody ready to try it on their own? Okay, let's try corn silage. We're gonna have 2,000 pounds of corn silage. It's gonna be 65% water, 35% dry matter. Same fractions again, protein, starch, and sugar, NDF, fat, ash. As a percent of the dry matter, we're going to have 10% protein, 37% starch and sugar, 46% NDF, 3% fat, 4% ash. So how much of each of those is still in the pile? How did I do? So this column, if this column adds up to 100%, this column has to add up to what? 700 pounds, does it? Probably within rounding error, what? 699, 701, somewhere in there, right? Everybody getting that? Was everything you hoped it would be? Everybody think they can do it on their own?
I think so.
Back row? Okay, so we got a homework assignment related to this. So I got a hard copy here. There's also a copy of it available on Brightspace. You have 6 problems, 7 feeds, so you're not going to use one. So first one is 2,000 pounds of hay. How many pounds of each of the components? 2,000 pounds of corn silage, just like we did in class here. So that's kind of review. Then we got 500 pounds of haylage, a ton of heifer grain, 220 pounds of TMR, and 100 pounds of soybean meal. So again, you got this hard copy. If you need another one, you got the PDF of this is up on Brightspace. Any questions? That'll be due next week. Okay, so we're going to move into ration balancing theory. So you have a handout of all this. So usually the way a computer program works, you're going to define the feed. Where have we heard that before? My definition of nutrition: define the feed, define the animal, define the interaction. That's basically ration balancing. So we need to define the feeds first. We need a composition analysis, either from a book or send it away, have it tested. If we're going to do balancing rations, we're going to need an inventory as well. We got to make sure that we can feed at the rates we're recommending and still have enough for next year. I think 3 years ago, we found out in October, no, it was November, we found out at the rate we were feeding haylage, we were going to be out by April. So we had to back off on our feed rate. It's easier to make adjustments when you're 6 months out as opposed to 1 month out. So we dropped back a pound and we were okay. We got through first cutting and had 3 weeks of fermentation before we had to start feeding it. So checking your inventories is important. Second, we'll go through, we've imported the feeds into the computer program. We start to define the animal we're working with. So what's the representative animal we're going to balance our ration on? We have to go through and define that animal. What's she doing? How old is she? Is she growing? Is she lactating? Is she pregnant? Is she gaining weight? Is she losing weight? All that needs to be put in the program. And then the program, once you describe that animal, will tell the needs associated with those activities. Third, we're going to balance our ration. We're going to take the feeds and put them with the animals and see if we can make them match up in some way. I usually balance first for NDF, then I kind of do protein and energy together. I was taught do energy first, protein second. I tend to do them at the same time in a computer program. I save minerals and vitamins for last. And we'll show you how to do that when we start doing things electronically. The last thing you do is you take a step back from your ration balancing and you ask, is this ration possible? You may balance it out and say, we're feeding more corn silos than we got. I can't feed that much. I don't have hay that's going to fit. The inventories aren't going to work. Or I can't buy that ingredient anywhere close. So is it physically possible? Can we do what we need to? And the last thing we'll have to do is check to make sure it's safe. Just because it balances out on paper doesn't mean it's going to be healthy for the animal. You may balance something out, says feed 30 pounds of distillers. That's not going to work. She's going to have a screwed up rumen. She's going to have milk fat depression. It's not going to work. You may balance a ration that calls for 3 pounds of blood meal. That's not going to work. And we'll talk about those guidelines as we get into late November. So, but taking a step back from what you've balanced and checking to make sure that, yes, this is safe and possible to feed to my animals. We're going to use the substitution method, and we're going to learn it manually first. The thing about the substitution method is you need to balance for as many nutrients as you have feeds. So if you got 3 nutrients, you're going to need 3 feeds. You can imagine, as you'll see as we go forward, it's ridiculous to start to do this by hand for 6 different feeds. So we're going to stick with 3 and 3. The nutrients that we're going to work with are dry matter intake. How much groceries is that cow going to eat? We're going to use some measure of energy. Today we'll use TDN. It's kind of antiquated, but it's going to serve our purposes well today. TDN is total digestible nutrients. TDN is the sum of the amount of digestible NDF, the digestible starch and sugar, the digestible crude protein, and then the fat times 2 1/4. Why do I multiply the fat by 2 1/4? We discussed that yet? We have, but there's 2 1/4 times the calories in fat as there are in those other fractions. So that's why we multiply it by 2 1/4. Remember 9, 4, 4? Those ratios. And the last nutrient we'll deal with is crude protein. So we're going to have 3 feeds in each ration, and they have to go into a specific category. We're going to have what we're going to call a 1 feed, a 2 feed, and a 3 feed. And you got to make sure you put the right one in the right location. We start out, I'll define those for you. This is your 1 feed, this is your 2 feed, your 3 feed. As we get a little farther in the semester, you're going to have to make those decisions yourself. So the 1 feed is always a forage. Relative to the other 2 feeds, it's going to have the lowest energy, the lowest protein. We try to feed as much of this as we can because it's the least cost item of all the things that are there. We get calories cheap, we get protein cheap. Our number 2 feed is our energy feed. This is what we bring in if we're short of energy. So it's high in energy, low in protein, and these don't specifically match the high, medium, and low we did for the feed ID. These are relative to each other. And it's usually medium cost. The 3rd feed is a protein feed. It's high in protein as you'd expect, but all protein feeds are generally high in energy as well. And generally our protein feeds cost us the most, so we want to minimize their use, trying to be profitable, trying to be cost effective. So we're going to deal with 3 rations. The first one we're going to try is just using the one feed, our forage feed only. What is the advantage of doing that? If I can get it done with just the forage, it's probably going to be the cheapest diet I can give that animal. If that doesn't work, we're going to bring in our second feed, feed 2. If that doesn't work, we're going to go and bring in our third feed. So what we're doing with the substitution method is we try the ration with feed 1 only. If that doesn't work, we move to ration number 2. If that doesn't work, we move to number 3. As a general rule in this class, I will make the third one work. I might also have one where 1 works, but we'll see those as we go along. So what we're going to do is we're going to have 3 different feeds here. We've got our hay, we've got corn, and soybean meal. So we're defining our feeds. We look at the hay that we have. We're going to say that hay is 40% TDN. So every pound has how many pounds of TDN in it? Every pound of feed. Every pound of hay dry matter. Going to have 4 what? 4 tenths. So every pound of hay dry matter has 1, 2, 3, 4 tenths in it. On a protein basis, it's only 10%. It's going to have 1/10 of a pound of crude protein. We move over to our corn. 1 pound of corn dry matter is going to be 80% TDN. So how many pounds of TDN am I going to have in 1 pound of corn dry matter? 8 tenths. 1, 2, 3, 4, 5, 6, 7, 8. 8 tenths of a pound in 1 pound. So it's mostly energy, which makes sense. It's an energy feed. Crude protein is 10%, so how many tenths am I going to have? Look at my dot. What do I got? 1/10 of a pound. So if I multiply 1 by 0.1, I'm going to get 1/10. Soybean, 1 pound of dry matter, going to be again 80% TDN. So 8 tenths of a pound in 1 pound of dry matter. But what happens to the crude protein? Goes up to what? 50% crude protein on a dry matter basis. So half of this 1 pound of soybean dry matter is protein. Brain is saying, well, you got 8 there and 5 there. How does that all add up? Some of this protein could be used for energy. So there's an overlap between the two. So I got my 3 feeds and I've defined them. So you'll also have a dry matter percentage on these. They're all 90% dry matter. We're dealing with dry feeds. The requirements for the heifer that we're going to balance rations for is going to be 15 pounds of dry matter intake, 8 pounds of TDN, and 1.9 pounds of crude protein. So I do my first ration. My first ration's gonna be all feed 1. It's gonna be all 4-inch. This pile is representing 15 pounds of feed. So I got 15 pounds of feed. How much? 15 pounds of feed, my dry matter intake is satisfied. How much energy do I have in this pile of hay? It's 15 pounds of dry matter. How do I figure that out? £15 times 0.4, right? So how many pounds of TDN are in this pile of hay? So 15 times 0.4 is going to give us 6. Is that meeting our requirements? No, we're supposed to have 8. We're 2 pounds short. So ration 1 didn't work. So what I want to do now is I want to substitute. Hence the name for the ration balancing system. I'm going to take 5 pounds of hay dry matter out. And I'm going to bring back in 5 pounds of corn silage, or 5 pounds of corn dry matter. I now have a pile on the floor that's 10 pounds of hay dry matter and 5 pounds of corn dry matter. Does that satisfy her dry matter intake requirement? 10 plus 5, yes, does. Does it satisfy her energy requirement? How much TDN, how many pounds of TDN do I have in 10 pounds of hay? 10 times 40% or 0.4 gives us 4 pounds. I got 4 pounds in here. I've got 5 pounds of corn dry matter. How many tenths of a pound of TDN do I have? I got 8 tenths in each pound. Times that by 5. I got 40 dots there, right? That's 4 pounds of TDN. So I got 4 and 4. Am I balanced for energy? Yes, I am. What about protein? How many dots do I have for protein? How many pounds of protein do I have in this 10-pound pile? 10%. So for every pound, I get 1 dot. 1/10 of a pound. 10 of those add up to 1 pound. Everybody with me on that? How many pounds of crude protein do I have in my corn? Each of these pounds of dry matter gives me 1 pound, 1/10 of a pound. Crude protein, 1, 2, 3, 4, 5. 5/10 of a pound plus 1 pound gives us what? 1.5 pounds. So 1 pound of crude protein.
1 pound plus.
We're not counting the dots. So we've got 10 tenths, right? Yes, there are. But you got, this is per pound of dry matter. There's 10 pounds here. So you got 10 dots plus 5 dots. Each of them is 1/10 of a pound. That's 1.5 pounds of crude protein. Is that enough? $1.9 is the requirement. Do I have enough? No, we're 4/10 of a pound short. So where do we go now? We go to our third diet that has all 3 ingredients in it. So what I'm going to do is take out 1 pound of corn dry matter, and I'm going to put back 1 pound of soybean dry matter. As I move from one grain, my feed 2, to the other grain, does anything change on an energy basis? I had this, now I've got this. Does it change? Is the energy the same? So the energy is satisfied. Dry matter intake is satisfied. Is crude protein satisfied? I have 1 pound of crude protein here. How much do I have here? I got 1 pound here. How many tenths of a pound do I have in these 3 feeds? 9. 1 plus 0.9, 1.9 pounds. I am now satisfied for crude protein. This pile here on the ground is now what that cow needs to eat every day. It's a balanced ration. There was Hayden pointed out, he goes, "You're not going to feed this to your cows, are you? What's wrong with it?" Way too much grain for him. So you go broke, effectively. But it would get the job done. And you'd have less manure, so maybe you have less to clean up. Everybody following that? I guess I should have walked through that. So we tried ration 1. Didn't work. We were short on energy, short on protein. We brought in the corn. Took 5 pounds of dry matter out, brought in 5 pounds of corn dry matter, substituting one for another. We were okay on dry matter intake. We had okay on energy. We had that 8 pounds of energy now, but we were short on protein. So going through and substituting that last pound of corn with 1 pound of soybean meal gets the job done. So can we be a little bit more quantitative than this just visual representation? This spreadsheet is up on Brightspace. So we're starting with the givens in our balancing. We have our requirements listed up here. 15 pounds of dry matter intake. 8 pounds of TDN, 1.9 pounds of crude protein. We have our feeds defined over here. And I'm going to use the color, that straw kind of tan color for hay, yellow for corn, and blue for soybean meal. Our hay is 90% dry matter, 40% TDN, 10% crude protein. Our corn, 90% dry matter, 80% TDN, 10% crude protein. Our soybean meal, our feed 3, is both high in energy and crude protein relative to the other 2. So visually representing the energy here, if this is 1 pound of feed, 4 of those are TDN, 4/10. So there's 10 blocks here. Each pound of feed has 4/10, 40% TDN. Corn and soybean, those are 1, 2, 3, 4, 5, 6, 7, 8, 80%, 8/10 of a pound for each pound. We look at the same feeds on a crude protein basis. hay and corn are 10% crude protein. So only 1/10 of a pound out of 10 is protein. Half of our soybean, 50%, is crude protein. So 5/10 for each pound. Everybody following that logic? Doing the same thing we did before, just a little bit more visual, quantitative. So we balance the first ration. We take that hay and we fill in all the way across with hay. So we got 1 through 15 pounds. Our dry matter intake is all hay. Did that satisfy our energy requirement? Dry matter intake is satisfied. Did it satisfy our energy requirement? Remembering back, no. You can see it visually here, right? If we have 8 pounds of TDN needed, how many squares have to be green down here? Not 8. 80. We need 80/10 to make 8 pounds of TDN. Everybody following that? So I've got 4 high and 15 across. How many squares is that? 4 times 15. 60. So I got 60 squares there. 6 pounds. I'm 2 pounds short. I've got to somehow add 20 squares. What about the crude protein? I take all of my 15 pounds here. I fill them up with hay. Each pound of hay has got 1/10 of a pound. That's 15 squares, or 0.1 or 1.5 pounds of crude protein. We're 4/10 short. So diet number 1 did not work. I need to go to diet number 2 or trial number 2. So I'm going to take out 5 pounds of hay dry matter. I'm going to bring back, substitute in 5 pounds of corn. So what does that look like on our spreadsheet? And again, the spreadsheet is up on Brightspace. So I take out 5 pounds of hay and I put in 5 pounds of corn. So I take this out from here and I take this over and put it in there. What happens each time I take a hay out and bring a corn in? What happens to my column? I get 4 more green squares on every column. So if I've got 5 columns and 4 squares, what is that? 5 times 4? 20. That's going to bring us up to 80 squares. We are now satisfied. 80/10 of a pound. I'm now satisfied 8 pounds of TDN. What do we got down here with our corn coming in to substitute for our hay? We got no change in the number of squares. The same amount as before. We're still short 4/10 of a pound. So I'm going to substitute in that last pound of soybean for 1 pound of corn. What does that look like when we plot it in? We take out the last corn here on the end and bring it in. So bring in the soybean meal. Does it change our energy? No, it's the same as it was before. It's still balanced. What happens with our protein? I gain 1, 2, 3, 4 squares. That takes me up to 19. 19 times 0.1 is 1.9 pounds of crude protein. my ration is now balanced for dry matter intake, energy, and crude protein. That's a visual kind of quantitative presentation. Now we're going to move on to using a ration balancing worksheet. In your packet, you have 2 sets of this form. You also have this form up on Brightspace. So once we start using them in class, we'll print them out front and back. You can either work front and back on a single sheet, or you can take 2 of them and flip one over and put them sequentially that way. I don't care, whatever you're more comfortable with. So this is going to walk you through how to balance a ration with the substitution method by hand. So we have our form here. This is for dairy cattle and TDN. You got your name, MID on top. The first thing we need to do in this form is define our animal. So determine the nutrient requirements in pounds per day for the animal described. So what we're going to do here is we're going to take a 750-pound heifer, gaining 1.5 pounds a day. ADG, everybody knows what that means or not? ADG is average daily gain. So she's got 1.5 pounds average daily gain. We're going to assume that she's eating 2% of her body weight for dry matter intake. Is that typical or not? Does anybody remember? For heifers. What?
Well, I'm out like from the video, right?
A little bit, but
That's like 2%.
2% of body weight is fairly standard for a heifer. You could probably get more in that if you lower the NDF, but 2% is fairly typical. So how do I get that 15 pounds of dry matter intake? I take the 750 and I multiply by 2% divided by 100 for 0.02. So 750 times 0.02 should give me 15. So that's where I get my dry matter intake. And then our TDN pounds and our crude protein per pounds are provided. We move down to step 2. We're not going to use reference numbers just yet. We'll get that to when we get our feed charts, and I'll tell you to look up feed 28, 56, and 107 and use them to balance the rations. So some people put those in, you don't have to, but I tend to put them on the answer keys. Then our feed number. What is our feed 1? Hay. What category is it? It's going to be a forage. Feed 1 is always a forage, so that's hay, haylage, corn silage. Feed 2 is what class of feed? Energy. What do we know about our energy feeds? They are high in what? Energy, but low in protein. Then our third feed number 3, is going to be soybean meal. That's going to be, relatively speaking, high in energy and high in protein. So all 3 of our feeds are dry feeds, so we're at 90% dry matter. Then we've got TDN at 40, 80, 80, crude protein 10, 10, and 50. So we're doing the exact same feeds again. We're doing it with the form. So those of you that are interested, there's a cheat sheet in the back that shows you how the information flows on this form. So following the arrows, what moves down where? How things are done. So on the lab practical, you will have this exam. Well, you have the net energy lactation form, not the TDN form, but it's the same. But you won't have the cheat sheet. You've got your instructions right on the sheet. It tells you what to do. So follow those instructions, become familiar with them, get used to moving everything down and through. So step 3, we want to balance for dry matter intake or run trial ration number 1 using only feed 1. So which is our feed 1? Hey, what is our dry matter intake requirement? 15 pounds. What is our TDN percent of our hay? 40, so that goes in here. What is our TDN requirement?
6.
No. 8. Should be written down from the top. So let's start to fill that in. So feed 1 is our hay. We're going to fill up her dry matter intake, so this should always be matched or met. It's always going to be 0. You're going to 15 is a requirement. That's what we're going to feed. So we're dealing with rations. None of the ones that we're dealing with going forward are going to be this clean. You're balanced if you're plus or minus 5% from the requirements. So how do I get that 6 pounds of TDN? Just like we did over there. 15 pounds of dry matter intake times 0.4 is going to give us 6 pounds of TDN. Where do I get the 8 from? 8 is from step 1, right? We bring that down from step 1. So 6 minus 8 is minus 2. I'm 2 pounds short of my TDN requirement. Am I balanced? No, so I got to keep going. That means I got to go to step 4. So balance for energy by first determining the gain in energy by substituting feed 1 for feed 2. So in this case, what's my energy change taking hay out and bringing corn in? So if I take 1 pound of hay out, bring 1 pound of corn in, what do I gain? 4/10 of a pound for every pound. So if I do that mathematically, I look at how much energy is in 1 pound of feed 2. How much energy is in 1 pound of feed 2? 8/10, 0.8. How much energy is in 1 pound of feed 1? 0.4. So how much is in 1 pound? 0.8 times 0.4. Every time I take out a pound of hay and put in a pound of corn, I gain 4/10 of a pound. The swap. So that's my gain, 4/10 of a pound. So where's this 2 come from? The amount you still need. So you're going to say we're 2 pounds short. That means I need 2 pounds. So we lose that minus sign. I bring down the gain from the line above. 2 divided by 0.4 is going to equal 5 pounds of corn that I need to add to make up that 2 pound deficit. Each time I do that, I gain 0.4 pounds. I do that 5 times. I'm going to gain 2 pounds of TDN. So I take 5 here, bring it down to here. So dry matter intake, where do I get that from? requirements area up top. I bring down the 5 pounds of feed 2. I subtract 15 minus 5. That 10 is the number of the new feed weight for feed 1. So now my next ration is going to be 10 pounds of hay dry matter and 5 pounds of corn dry matter. So we go to the next sheet. So what is my feed 1? Hay. Feed 2 is corn. How many pounds of dry matter do I get from hay? 10. 5. We get that from the bottom of the previous page, right? They're going to add up to 15. My requirement is 15. I've got a 0 difference. Where do I get my TDN percents? Back in step 2, right? We bring them forward. Same with our crude protein numbers. We bring those forward. Where do I get my requirements from? Step 1. So requirements going across. We have our 1, 2, 3 requirements. We get those from step 1. Okay, how do we fill this in? We've got hay, we've got corn, 10 pounds of hay from the bottom of the other side or the bottom of the other sheet. 10 pounds of hay dry matter, 5 pounds of corn. Everything balances out there. From step 2, we've got 40% NDF or 40% TDN for our hay, 80% for our corn. We multiply the dry matter pounds times the percentage divided by 100. That's going to give us 4 pounds of TDN coming from both of those sources. So 10 times 0.4 is going to give me 4 pounds of TDN from the hay. 5 times 0.8 is going to give me 4 pounds of TDN from the corn. I add those two together. I'm provided with 8 total. My requirement is 8. I am balanced for energy. How do we get the percent crude protein from step 2? How do we get this last column? You're going to multiply the dry matter pounds times the crude protein divided by 100. So you're going to skip over to get this last one. So 10 times 0.1, 1/10 of 10 is 10 or 1 pound. 5 times 0.1 is going to give us a half a pound. So 1 plus 5 is going to give us 1.5 pounds provided. Our requirement from the step 1, 0.9. We are 4/10 of a pound short. That is more than a 5% difference. We need to continue on to our third ration. So step 6, balance protein by determining the gain in protein pounds by substituting feed 3, which is our soybean meal, or feed 2, which is our corn. So if I go from 1, if I subtract my soybean meal, when I subtract the corn, what do I get? How many tenths of a pound of protein do I have in my soybean meal? Feed 3. Half a pound for every pound of dry matter. What about my feed 2, my corn? What do I got? 1/10 of a pound. 1/10 of this is protein. So if I take a half pound minus a 1/10 of a pound, that gives me a gain. If I take out crude protein put in soybean, every time I make that swap, I gain 0.4 of a pound. Substituting. So my need gets moved down here, my gain gets moved down. 0.4 times 0.4 gives us what? 1. As a general rule, I do 1 decimal place for dry matter intake, 2 decimal places for energy, and 3 decimal places for crude protein. That seems to work best. And we'll go over that, but you can still round to whatever you want, and it'll still work out. Okay, so we've got our new amount of feed 3, we've got our amount of feed 3 we need. We've got our old amount of feed 2 that we're going to substitute in feed 3 for. So our new amount of feed 2 is 4 pounds. So we're back to 10 pounds of hay, 4 pounds of corn, and 1 pound of soybean meal. Our third ration, we're going to go down and take care of that. So where do I get feed 1? How do I do this row? I can copy down from the top of the page. It's exactly the same. So hay is 10 pounds, corn is 4 pounds, soybean meal is 1 pound. I get the TENs from the previous page, step 2. I get the crude proteins from step 2. I multiply my dry matter pounds times TEN to get TEN pounds. I multiply dry matter pounds times crude protein divided by 100 to get crude protein pounds. Take a crack at filling that table out. I have a stapler. If you want to rip things apart, you're more than welcome to do that. So how did I do? Hay, corn, soybeans, 10 pounds, 4 pounds, 1 pound. We are balanced for dry matter intake. I got 40, 80, and 80 for hay, corn, and soybean meal, TDN percent of the dry matter. That means hay is contributing 4 pounds of TDN. Corn is contributing 32, 4, 8, 8, 8, and 8. And then 0.8 pounds from the soybean meal. Add those up. I got a total of 8 against my requirements. I am balanced. Crude protein, hay and corn are 10%. Soybean meal is 50%. I multiply my dry matter pounds by my percent divided by 100. And I get 1 pound of crude protein from hay, 0.4 of a pound of crude protein from corn, and 0.5 pound of protein from my soybean meal. Add those 3 up, 1.9. That matches my requirement. I am balanced all the way across. Any questions on how we get that? What's step 8? As fed pounds, what do we call that? We balance on a dry matter basis, we feed on an as fed basis. What is this? Mixed sheet for 1 cow. So we have our dry matter pounds that we have from our balanced ration. We have our dry matter percents. How do we get from dry matter pounds to as fed pounds? Everybody remember? Or look on your cheat sheet. We divide. What do we always know about our as fed numbers? Always bigger because we've added water back. So this divided by this. So 10 divided by 0.9, 4 divided by 0.9, 1 divided by 0.9 is going to give us these totals. This is what we have to put down in front of that heifer on an as-fed basis to keep her growing at 1.5 pounds a day. How your brains feel? Everybody's sort of following that. So again, for the lab practical, you're going to do 2 rations. You're going to have these forms or the equivalent in net energy lactation. So learn to follow them. You got your cheat sheets there to help you work your way through. There are students that have enjoyed this experience and called this process meditative. I just put my numbers in and I put my calculator and I just plug and chug. Some people also find this very excruciating. So I tried to present the same ration 3 different ways. Some people, the last example is pure math. The first example is pure visual. The one in the middle is somewhere in between. Think about what you're doing, whatever context makes sense to you. Are you a visual person or are you a math person or somewhere in between? Work those 2 through. Any questions on how to do this? You're not going to have any homework with this week. The idea of this week is to present it to you so you get the hang of it. Next week, we will balance actual rations. The time is yours to do with as you see fit. You can work on your homework. I'll be here for another hour or so. Or you can go home, whichever you want. You can ask questions, whatever you want to do.
I don't know.